Hello, welcome to Computer Architecture. In this mini lecture, we are going to talk about how MIPS supports procedures in computers. So what is a procedure? Sometimes we call it a function. It's actually a store subroutines that will take some input, does some computation, and returns output to the main program. And it's an important way of realizing abstraction. Here is an illustration. We have main execution thread, main program, and on the right-hand side, we have the procedure. And there are 6 steps to implement this idea, this concept of procedures. First, the main thread, the calling program, will need to share the inputs, share the parameters in some place that's accessible by the procedure. And then we need to transfer the control. And then the procedures, the CPU needs to obtain resources, the storage resources for the procedure. And the procedure can execute the instruction to perform the computation. And once the result is obtained, the output needs to be stored somewhere so the main thread can access it. And then the procedure will return the control to the point of origin, the calling program. And by convention, MIPS has several registers to use for this procedure calling. So the first one, A0 to A3, are used for sharing input, and B0 and B1 are used to share output. And then very important one, the register, the address register RA is to store the address of the point of origin. Then how do we use this is the JAL, jump and link instruction, which specify the procedure address that we need to jump to. And this instruction does 2 things at the same time, okay? Or alternatively, they do this atomically. So the first one is jump to the address specified by the first parameter. And then the address of the calling program will be stored inside the register. This address is called return address. Then the terminology that we will use is the calling program. Sometimes we call it caller, which is the main thread, and it's calling the callee, which is the procedure. And then remember, we also use the program counter to store the instruction that needs to be executed. All right, so one exercise for you is to figure out that when we say that we use JAL, actually what is the address that we will store inside the register return address, or register RA. All right, remember that we have 6 steps. Then now let's look at how MIPS achieve that. The first one is the input that needs to be shared between the thread, main thread, and the procedure, and that's achieved by the input register A0 to A3. And then when this up arrow, the top arrow is the transfer control, and we achieve that by calling the jump and JAL instruction, jump and link instruction, so that we update the correct address to the program counter. And then here the procedure, the CPU needs to allocate some storage, which is inside the stack that we will see later. And then the CPU just follow the instruction of the procedure, get the data, get the output. Those output will be stored inside B0 and B1. And then it will return the button arrow to the control of the main thread by using jump register, which jump to the return address that's stored inside RA. What happens if we need to have store more data? We need more register. Then we can actually spill those register inside the memory. And the particular data structure that we use is a stack, where a stack is a last in, first out data structure. And then there's one important register, which is SP, that is used to store the value that represent the most recently allocated address in the stack. And by convention, the stack actually grows from higher memory address to lower memory address. So whenever we push the value inside the data structure, actually we need to subtract the value from SP. This is an illustration. We have high memory address to low memory address. When we push the content inside the stack, actually we are moving the stack pointer from top upper place to lower place. So that means we are subtracting it. And when we pop the value, then actually we are increasing it, the stack pointer from low to high. Then there are two different types of procedure. The first one is called a leave procedure. This type of procedure, it does not call other procedures, so it's pretty simple to deal with. But the other type is that procedures are calling procedures. Then what kind of challenge will you face if you need to implement this kind of nasty structure? The important one is that the register may be overwritten. If you think about it, right? If something inside RA, the return address is overwritten, then you don't know where to return to the main thread. And obviously this is not good because you get lost. You can never return the output to the desired place. So one solution that's simple is that we can store the value inside register to preserve it onto the stack, onto the memory. And there are two types of data that we need to deal with. On the left-hand side, we have the ones that need to be preserved onto the memory. On the right-hand side, there are something that we don't really care about. So there are safe register, stack pointer register, there are something, the address inside RA, and also stack above the stack pointer. For example, the blue one is the thing that we compute in the procedure. So we need to do that. But on the right-hand side, with a stack below the stack pointer, actually those space are not needed at the moment, are not used by the procedures. So that's why they don't need to be preserved. Okay, similarly, the other thing, like temporary register, they also don't need to be preserved. Now, the exercise for you is that stack, we might also need to preserve it. What do we mean by preserve stack? And then stack pointer, how do we remember that? Okay. Now let's take a closer look at the stack. Maybe we need something else. What are the things that we need when doing procedures? We might need to have some local variables that are not stored inside a register. Those are called local data structure or local variable. So that's also called procedure frame or activation record that we need to deal with or we will need to use inside procedure. And some of the MIPS design actually introduce another thing called frame pointer FP. More formally, it's a stable base register that's used inside in the scope of procedure for local memory referencing. In other words, is that within the procedure, you need to find some local data. This FP will make it easier for you to find the data. All right. And something for you to think about is that, do we really actually need to have FP? Then what happens if we don't have that? What's the benefit of using FP? Now, this is an illustration of the stack allocation. Remember that when doing the procedure, we need to obtain the memory space that we need to use. And then suppose we have FP and we also have stack pointer SP. So before that, it looks like this. Now, during the procedure, we're doing some computation, we need to store something, and then the top part is specified by FP, and bottom part is specified by SP, stack pointer, and there are a bunch of things that we might or might not need to store inside the stack. Here, just like, for example, you might need to store those things. And after the procedure is completed, you don't need those data, so you free those space and then you return back. Then that's how you get the FP and SP to the original point. Then once you have an understanding of this, now we can look at how C programs deal with the memory structure. And they are both the stacked variable and dynamic data structure. So we have high address, low address, some of the most bottom address are preserved, program cannot use, and then we have program counter, Let's specify which line of code that we need to execute. And that's inside the text segment, which store the program code. And we also have the static data, which is pointed by the global pointer that make it easier to get to those static data. And more interestingly is that in C, we have this idea of dynamic data because it allows the programmer to directly handle memory usage. So for example, we can use malloc to get more data for our data structure. That's like where the dynamic data part, which is called a heap. And then we can use free to get more data, more memory space. And then we also have this stack place, right? That's where we deal with the procedure. If you need something, you need to store those things, some value that's beyond the register to use, or if you have a nested procedure, then you need to remember those things, store those things inside the stack. Okay, so a short summary is that we talk about how MIPS design enable the procedures. And then once we understand the procedure, we get the idea of a stack and how C manages its memory.